Hi, Dave.
Hello, how are you, Seb?
I'm great and really happy to have you for this new episode of Data by Design. Um, so we start communicated a few weeks ago on LinkedIn, but maybe some of the followers don't know you yet. So can you just make a short introduction about who you are and what you are doing in the data world?
Sure, and thank you for the opportunity to speak with you today. Um, Again, my name is Dave Cameron. I am a data analytics professional. I might have been a data scientist before the term existed. I have a master's degree in applied statistics, which meant there was a heavy orientation on how data is set up, programming around it, the apps, not just the statistics itself. And I've done that for a number of years for large corporations. My last role ended 6 years ago. I was the global vice president for the Nielsen Company. Nielsen is in 100 different countries, and I was in charge of all of the, I'll call it the data science behind Nielsen's global segmentation. The role ended. Nielsen opted to spin that business off in 2017. And since then, with my experience, I've done two things. I started teaching at universities. I have a role at three of them right now, and that's a way for me to give back. And I also do consulting. So I don't do full time work for any corporation. What I do is I come in and I help people set up a system. They may not have something in place. Usually they are smaller companies, maybe 25, 30 people, and they need some expertise to say, how do we set up our data warehouse for analytics? How do we make the best data driven decisions out of this? What kind of processes, systems, schemas do we need? And I'll come in and it will typically be maybe a 3 month project, and then I'll leave and they'll turn it over to the full time employees.
Great. And during the preparation of the interview, you told me about something really interesting about the class you teach and the relation between data and the business teams, because finally data is all about business.
Right now, I'm trying to remember what that was, but one of the places I teach, I'll give them a plug here if I can. It's called the Lake Forest Graduate School of Management, and it's a master's program, a Master of Business Administration or MBA, and they specialize on leadership. But back in many years ago, when you got this degree, you would specialize, maybe finance or marketing or operations. Well, in today's day and age, data is just so pervasive. You need to understand how to work with it. You need to have a way to decide what data you use and how do you organize and access. So, this program, they started a specialization in data analytics, just like you'd have a specialization in marketing or operations or finance. And I was brought in at the start, at inception, and we have four courses. The first one is data modeling, which I think is a big focus of our conversation today, because if you don't get the data model right, nothing else matters. And it's mastering that. And then moving from there into a second class is an introduction to machine learning and AI. So then you can set up the tools to leverage the data model and make your predictions and make your decisions. The third one is data visualization, so there's a way to look at it and it is more clear. And then the fourth one is how do you present to management? How do you build a data science team? What are the different roles and that sort of thing? And the program has been going very well. I teach often the first class and the last class, and so I'm excited to talk about data modeling, but I think that it just shows how progressive institutions are recognizing the importance and moving in that direction.
Yeah, probably I need to create another YouTube channel to talk about data literacy and data governance in more general ways. But let's begin with the data modeling part. You provided me with a very interesting use case about the marketing part, in which you are also an expert. Can you tell me a bit more about this use case and the domain we are going to talk today around the marketing coupons?
Sure, happy to. So when I was at Nielsen, we did a lot of work with what we would call consumer packaged goods manufacturers and retailers. This type of things you would buy maybe every week, like carbonated beverages like Coke or laundry detergent, Procter and Gamble products, frozen foods. Not so much fresh stuff. They were more packaged goods that were made by somebody that has a barcode out there. So I use as my example my handy dandy bottle of Diet Coke for today, where Coke understands how much they've sold because they've shipped it to various retailers. So in the U.S., it could be Walmart or Kroger. I'm talking to you in France, it could be Carrefour. In the U.K., it could be Tesco. And they know how much they've shipped, but they don't know when it actually sold, and they don't know what their market share is versus their competitors without a company like Nielsen that would come in and measure that. And what they wanted to do was say, well, this is great, you've measured it. How do we, if we are Coke, how do we improve this? How do we go from measurement to say, how do we make things better? And their idea was to send coupons to people. And if you're a grocery retailer and you have a mobile app, okay, so people download the app, they keep their shopping list on that app, right? And within that, they might say, oh, this week I need to buy Tide laundry detergent. I need to buy some more Diet Coke. I need to buy some more frozen pizza. And they have their list. But maybe they don't have Diet Coke on the list. So what the retailer would do is work with Coke and say, great, let's offer them a coupon. Since they are not going to buy it for full price, maybe we take 20% off and we offer them a coupon, and that might be enough to motivate them to buy. And then the retailer's happy because they bought more, and Coke is happy because they bought something they wouldn't buy otherwise. And so in order to send those coupons to the phone is very complicated. You need the process to do it, but you also need to decide which coupons to send, because the retailers work with many, many, many suppliers: Procter and Gamble, Unilever, Coke, you name it. There's literally 100 of them, and they might have 50, 60 different coupons to choose from, and so there needs to be some sort of process to send the right coupon to the right person. Or how would I say, when you have your phone, let's say you open it up and you might see the first 2 or 3 coupons. Most people don't really scroll down to look for coupon number 5, number 10, number 20. So even if you sort them in order of relevance, by the time you get to number 10, very few people actually see it. So the goal of this project was to help both the retailer, the manufacturer, and the end consumer by sending them the best coupons that would make everybody happy.
Okay, so if I try just to sum up, so you have three main stakeholders, so the consumers, the retailers, and the manufacturers. And of course, I can imagine that they have many different objectives or different goals. Probably the consumer want to make some savings. And what are the objectives of the each stakeholder in this process?
That's a great question because they are different, and sometimes you even need different data tables, models, depending on whether you're working with the manufacturer or the retailer. So, again, from the retailer perspective, they have to optimize. They have limited shelf space, right? It's a physical store, and there's only so much that you can store in there. So, what they do is they set up, I would say, maybe 90 different categories. And a category would be like frozen pizza or laundry detergent or canned soup, or again with my Diet Coke, carbonated beverages. So they are looking to say, we want to do the best we can for our business. So when they're looking at coupons, they want consumer interaction. They're not looking to make more money off of it. They're looking for the customer to buy more. So their ultimate target is, did people click on the coupon? Okay. percentage of people, number of people that clicked on the coupon. From the manufacturer's perspective, they're looking for the same thing, except they also don't want to lose money off of it. So what they need to do is they have a component, because they're going to discount the price for the retailer. So if the retailer is selling something for $2 and you take that 20% off, the retailer doesn't lose that 20%. Coke loses that 20%. So Coke wants to make sure that, well, don't send coupons to people who would buy it anyway, who would buy it without the coupon, because we don't need to give them 20% off. They buy it anyway. So there, as you surmised, there are different objectives. Both parties want the coupon clicked, but Coke only wants coupons to go to people that wouldn't buy it without the coupon, because if they buy it for full price, why do you need to send them the coupon? Why do we lose the money off of it? And whereas the retailer doesn't care, because they just want more interaction. They just want more coupon clicking.
And of course, the consumer want the coupons, whatever it takes.
Exactly.
Okay, very clear. And so this difference of paradigm is maybe also accompanied with different terms of different meanings for the same objects. Um, did you have to solve some ambiguity about some vocabulary, specific terms in this case?
Yeah, I'll give the example of toothpaste. So we have the retailer sets up. Um, I don't try to not use acronyms. They set up what they call a hierarchy of categories, and they might have a category called um, oral care. Oral meaning like for your mouth and that. And they would include toothpaste and the rinses, the mouthwash, that sort of thing, like Listerine here in the U.S. And that's how they define their department. But Colgate is one of the biggest, if not the biggest, toothpaste manufacturer in the world, and Crest by Colgate, Crest by Procter and Gamble is also well up there, and they may not look at it the same way. Colgate says, well, wait a minute. We only make toothpaste, the stuff you go out in your tube and everything. We don't make the stuff you swish around in your mouth and all that. So we don't want that included in our category. So we, Colgate, are defining the category differently than you, the grocery retailer, are defining the category. And so they might use the same words, Seb. They might use, toothpaste. They might use oral care, but there are little differences between what goes into that category. So when we measure, Colgate wants to know their market share relative to only other companies that make the stuff in the tube that you take the brush and you do that with. But the retailer looks at it differently and says, oh no, we do everything for the mouth, anything you rinse, anything like that. And so we need to measure the metrics two different ways. For the retailer, it needs to be the way they define it, and the manufacturer needs to say their share the way they want to see their share. But what makes the ambiguity, to come back to your question, is they use the same word. They both call it the same thing, except they mean different things.
Yeah, and so two different paradigms once again for this category. Um, and so this reflects, of course, I believe, a difference in terms of perimeter of the also the solution you had to design. So how did you reconcile the goals of these three stakeholders, or mainly maybe the manufacturer and the retailers first?
We ended up setting up a data model for both, where we would define the category. In this specific example, we would define the category the way the retailer wanted, and we would define the category the way the manufacturer wanted. And when we actually built our inputs, we included the oral care mouthwash type of things for the retailer, but we excluded them for the report when we sent it to the manufacturer. Now, having said that, when you actually build the model to decide what coupons people get, you need to make sure that both inputs are taken into account. So it literally ended up being two separate equations that would decide what coupon people would receive. And then we would take, say, a weighted average of those equations where we would say, okay, we can't just optimize for one party. We can't just optimize for the retailer, or we can't just optimize for the manufacturer. So what we did was we said, well, in this case, it might have been we'll take the retailer times zero point 0.6 and the manufacturer times zero point 0.4, put it together and get our final decision based on that.
Okay, very clear. When you had to reconcile this vision and even for the category, for example, how did you ask to get the data that was available, and how did you found out that they were not talking of the same thing or talking of the same thing with different words?
Oh boy, that's a good question, because whenever you start with any kind of data-based problem, you need to make sure you understand the context, right? If you just plunge in with what you think, you may not know what's going on. So I learned to ask a lot of questions. So the data that we received was from the retailer system that came off the mobile app. So again, for this grocery retailer, all of the data they had were from people who had those shopper cards or that had the apps that would basically opt in to have their data stored. And so I asked for the last 12 years worth of data from, 12 months worth of data from that retailer by customer. So every customer, I might have 40 transactions over the last 12 months with everything they purchased, and they would have a code that would be, the code that's on the package, that the barcode that gets scanned. They would have that code on there. Then they would have a name that matches to it from their system, and they would have a category. Then from the manufacturer, like a Colgate or a Procter & Gamble, I would ask them for all of the products that are included within their category. And then I would do a comparison. So I could see that for the retailer that, oh, I look at toothpaste and I see, oh, here's Crest toothpaste and here's Colgate toothpaste, but here's Listerine mouthwash. And then I look at Colgate's list and I say, wait, they have everything they list here is toothpaste. They don't list any mouthwash. So I would be able to see that. Now, there were 15,000 different items on this list. So it wasn't a matter of loading into Excel and looking at it one by one. You needed to have some way to put the data together and say, let's compare. Let's just build this model and count the number of items from the manufacturer, count the number of items from the retailer, and see if they match. And so, for instance, for carbonated beverages, they did. If I looked at Coke and I looked at this grocery retailer, the number of items was the same. If I looked at toothpaste and I looked at what came from Colgate versus what came from the grocery retailer, they were not the same. So when they were not, that's when I'd open up that Excel sheet and look to see what the differences are and use my experience, use my domain knowledge. And if I didn't understand, go back and ask both clients, both stakeholders, ask the retailer, ask the manufacturer, what am I missing?
Yeah, so you had to crunch the data and first crunch the metadata and then crunch the data to have a clear mapping of the two businesses. Okay, very clear. Another question that is just really correlated, I believe, is what about the data quality? Because maybe for the category, if you have only, let's say, a few hundreds of category, it's quite easy to see what's going wrong. But as you mentioned, you needed to also compare the number of products into each category, and I can imagine that there are a lot of products for retailer and manufacturers.
Yeah, and actually the first step was when the data came in, I talked to the various stakeholders to try to understand the data. And then the first thing I asked a person on my team to do was to sum up the total amount spent for the last 12 months by customer. So again, it's a US-based retailer, so we added up the number of dollars that they spent in this store over the last 12 months for customer 1, customer 2, customer 3, and so on. And 99.8% of the numbers were under 3,000, meaning they spent less than $3,000 over the last 12 months with this grocery retailer. Now, this was a few years ago, and I thought about it, and I said, okay, weekly, 50 weeks in a year, maybe 3,000 divided by 50, that's $60 per person. Okay, that sounds believable. It's not going to be the only place they shop. They're not getting all their groceries from there. So, okay, I get that. But the other 0.2% were over $20,000. And I didn't have anybody between 3,000 and 20,000, right? So why did I have 0.2% over 20,000? And a lot of people don't necessarily think to even look at the data at that aggregate level. But this is just how I've learned. I'm curious by nature, but also just my years of experience in getting here. Do you know what it was? Do you have any guesses as to why there were some people that spent over $20,000?
No idea. They are they are buying some hardware or for cleaning machines or things like this.
Now, as some people have guessed before, oh, it's for their church or it's for a scout troop or something. And it's like, actually, it was the cashier card. I don't know how other retailers work, but if you've been to a retailer and come in and say, before we had mobile phone numbers and they could look it up on your mobile phone, the retailer, would have everything stored by just the card number. And so they didn't have a way to link it to the mobile phone. So again, when they built their data model, the primary key was the card holder. They didn't even have a field for mobile phone. So what happened is if somebody came in and said, oh, I forgot my card. Well, now you just type in your phone number. But then it was the cashier would say, wait, let me scan it. And so it never got applied to the individual consumer. It got applied to the cashier, the person working and scanning all the items at the checkout, at the point of sale. And so, of course, it would be a big number because it would be however many times people forgot their card. That cashier is working there 35, 40 hours a week. She or he comes back and has, $50,000 worth of purchases that aren't theirs. And so it was things like that. I mean, today they've learned from this and they've added to their data model, we need to capture the person's mobile phone number, but that was a learning experience. I mean, this is iterative, right? You set up your model and then you find things that could be improved and you add to it.
Yeah, and that's where the when the data quality meets reality, so sometimes it's just to give the incredible explanations. Very interesting, Dave. And now can we just dive into the model so that we can see what it looks like and the way you represented the reality of this process for the marketing coupons?
Absolutely. Thanks for asking. And this is a very basic class diagram that is used for the orders that come in. So what I mean by an order is when somebody goes to the store, to the shop, and they buy something. So it's not that they're ordering online, they could be, but it's more frequently, since this is a grocery retailer, that they're coming into the store. So there are four things we need to track. Each customer separately, right? Each customer, do we send them a coupon? Do we not send them a coupon? Did they use that coupon? And then the order, what did they buy? What are all the different products they bought? So the relationship is a one-to-many because each customer comes in and they buy more than one product. You don't just go into a grocery store and buy a bottle of Diet Coke and leave, usually. You buy laundry detergent, you buy soup, you buy breakfast cereal, you buy all sorts of things. And so there are many orders for each customer. And then we need to link the order to the product because what comes in from the customer is the barcode. So when it gets scanned, let me go back. The customer, we have their ID, we have their name, we might have their address, we now have their mobile phone number. On the order, we have the barcodes of everything they purchased. But I look at the barcode and I have my bottle of Diet Coke here and it's got a number and it's 12 digits. And that's nice. What does it mean? So we have a product table that matches each product to the order, and inside the product table it gives you the ID, but it also gives you the price, it gives you the type, it gives you the name, so it tells you, oh, it's Diet Coke, it's a half a liter, it is the price is, whatever the price is, and so on. And each product, it has a separate line in there. So in the order table, a customer might order, when they go to the store, they might buy 40 different items and put it in their grocery cart and come out. The product table has a list of all 15,000 products that are sold within that retailer. And then the final table on the left is stock. Stock means how many are left within the store. A bad thing would be to send someone a coupon to buy Diet Coke if there's no Diet Coke left in the store, if everything's gone, if they've sold it all. So if the retailer has sold all the product, then people can't use the coupon because there's no product left. So you need another table that tracks how many are there. And once you get below a certain number, maybe say, oh, as long as we're over 20 or 30 or 40, we're okay. Once you get below that number, you need to order more. And so the stock table only matches to the product because it's only keeping track of how many of that product you have in your store. The product only matches to the order because when you order these products, you just get this barcode and you need to understand, for humans like us, what does that barcode mean? Is it Diet Coke? Is it Colgate toothpaste? What is it? And then you match the order to the customer, and each customer is your end goal, right? Each customer is, here's the person who's buying, here's the person we're going to send the coupons to. You don't match customer to stock because that's not a direct linkage. Stock is only to make sure you match it to the product and you have enough of each product in the store. So the data model is set up this way to ensure that you can store all the data. And when you realize let's take a retailer like Walmart. Walmart is the biggest retailer in the US. They have 3,500 physical stores in the US. And they have 15,000 items in each at least. You multiply that together, and then you try to add in customers and try to add in information about product, and pretty soon you could have a table of 47 billion rows. So you need to be very careful on how you put this together, and the reason for doing this is because you don't want to have one table that is just so big that you can't just query it and get an answer.
Yeah, that's a lot of data. And for example, so I imagine the category or the categories, depending on the manufacturer or the retailer's view, is was in the product table.
Right. So this is actually, this class diagram is the retailer's class diagram. So it's there because the orders are what you bought from that retailer. So the product is the way they categorize the product and what they have in stock. We would have a similar table for the manufacturer, but you would not have the customer as part of it because the manufacturer does not sell directly to the customer. The manufacturer sells to that retailer. They sell to Walmart. They sell to Tesco. They sell to Carrefour. They don't sell usually to the end consumer. Maybe you could buy online, but that's not really a big part of this model. And so I brought up the retailer one because this is the one that ties directly to the end consumer.
Okay, in the order tables, so you had a lot of information about the habits of the customer, and I imagine that you run a lot of algorithms to try to understand which customers, sorry, are going to buy or not Diet Coke, or at least if they have this item on their shopping list.
Yes, so because people have downloaded the app, they have given the retailer permission to understand their shopping habits. So what predictive modeling needs to do is to look at their purchase patterns and to see what they've bought in the past and how frequently they buy it. So let me continue with the Diet Coke example. If somebody buys Diet Coke every week, we don't send them a coupon because they buy it anyway. But if they buy it maybe once every 2 or 3 months, then we send them a coupon to encourage them to buy more. On the other hand, if they never bought it, then maybe we don't send them a coupon because they've never bought anything in that category. If they buy a competitor, maybe they buy Pepsi, we may still send them a coupon because we know they are a customer of that category. But If they never buy Coke, they never buy Pepsi, they never buy anybody in that category, then we don't send them a coupon because we understand they're just not a customer of that category. So there needs to be both rules and predictive equations. Rules meaning if you never bought from that category, you don't get a coupon. Or a rule would be if you buy Diet Coke every week, you don't get a Diet Coke coupon because you buy it without anyway. The predictive equations come into play when you look at things like what else is bought with it. So when Crest introduced a new concept called white strips, again, Crest is one of the largest toothpaste brands in the world, and white strips are these things you put on your teeth that make your teeth whiter. They cost a lot more, like 3 times what toothpaste cost, and you buy it in the store, and it was a new product. So how do you decide if you give someone a coupon? Well, here's where the predictive model comes in place. As you mentioned, Seb, you look at the market basket, you look at what else is in the basket, and you see what correlates with it. A standard example is people who buy tortilla chips also buy salsa. You sit down and you're watching a sporting event and you get the chips and you dip them in the salsa. And so people usually buy them together. Or if you buy breakfast cereal, usually you buy milk to go with the breakfast cereal. So there are some patterns that you can look for. So with the white strips, we looked for patterns. We looked for other products customers would purchase that would go with that. And it could be people who bought a lot of coffee because coffee stains the teeth. And so it's something that helps with that. It could be people who buy chewing gum. Chewing gum is another one that you chew for a long time, and you come out of there and say, okay, well, then you need something to whiten your teeth afterwards. But people who just bought mainly like fruits and vegetables and fresh products and did not buy many packaged goods usually didn't buy it. If they bought more natural products that you could just brush and stains go away, you don't need to pay the extra money for the white strips. So a long way of answering your question is there are both rules based on what other people bought, and there are predictions based on likely behavior from what other people have done.
Yeah, that's very interesting, and that will lead me to my next question. And how did you know that you were right with this prediction? And um, uh, how did you measure the success of your app?
Um, we did a test versus control. So what we did was we took their customer base and said, okay, 10% of them really don't get coupons. And then 90% of them get the coupons from, well, that's not really true. 10% of them wouldn't get coupons using our algorithm. They would get coupons using the same thing that the retailer did before, where, oh, everybody gets the Diet Coke coupon, or everybody gets the White Strips coupon, or nobody gets it. And that was our control group. These were the people that whatever the retailer did in the past, however they made their decisions, we would stick with that. Then we had a test group that we would say, okay, we will send them coupons based on our data model and our decisions based on the data in that model and see what the difference is. And we ended up doing 12% better based on coupon redemption using our model versus the way that the retailer had done it before in a real test, where we ran it in the market for 4 weeks, where the retailer had, 100,000 people that got the coupons the way they would normally do it. And then for the same 4 weeks, we did a different 100,000 people that would get the coupon the way our new algorithm would produce it. And our new algorithm had 12% higher coupon redemption than the way the retailer was doing it without our methodology.
That's a tremendous increase of the sales. I mean, so very impressive. Congratulations. For how long did you measure this? And was it something that helped you um, improve your model? I mean, your analytics model.
Yes, ran the test for 4 weeks. We waited one more week after the test was over to give the chance for any new data to come in, and then we took it from good to better. We took the information we learned and we iterated. So, each time we would do something, we would learn from the previous example and make little changes as we went through. And oftentimes it was because you learn more. Each time you do a test, you learn more. So we might be able to improve that 12% to 13% the next time, or 15%. What we found is the percent improvement got smaller and smaller over time. So I'm going to make up an example. I don't remember the exact numbers, but I know the 12% is correct for the first time through. Okay. Maybe next time we got to 15%. Then the time after that, maybe 16. Then the time after that, maybe 16 and a half. So it got to the point that at some point we just stop and say, yeah, the improvement is no longer worth the added work. It's time to move on to the next project.
Okay, thank you for all your expertise and all your explanation about this use case. I believe it was very clear and very insightful for all the people that are going to watch this video. Maybe to conclude, what would be maybe one advice you would give for people that are starting with data modeling or that would like to learn more about data models?
I would say first thing is the mindset. Always be curious. Use the example I gave where I looked at the total dollars spent over the last year for each customer. It was very easy when you run that through anything Excel, data visualization, SQL, doesn't matter. You can see very quickly that, wait a minute, everybody buys 3,000 or less, and then there's this small number of people that buy 20,000 or more. Anybody looking at that data is going to know something isn't right. So the first thing is dig into it, be curious, look, try to find things that are wrong, and then get organized. Once you do that, Seb, you asked the question about, well, there's so many categories. How do you decide the differences between how the retailer has it and the manufacturer has it? You need to go back to these stakeholders. You need to ask them the questions. I can't make the assumptions. I'm not the expert on the retailer categories. I'm not the expert on the manufacturer categories. They are. But as I look at the data, I can come up with the right questions to go back and ask and a way to set it up. So when I gave that example, I said, I took all the items that were in Coke's category, and I said, let me count up all the items the way Coke counts it, and let me count up all the items the way the grocery retailer counts it, and I got the same number. Well, I didn't count them. I put it into a pivot table in Excel, and I got the same number, right? Then when I did the same thing for Colgate and I got a different number, that's when I realized I need to go back to Colgate and I need to go back to the grocery retailer. But I can't just go back and ask, hey, what's different? I then go in and I look and see which ones don't match. And that's when I realized, oh, it's all the mouthwash. It's all the stuff you rinse around in your mouth and everything. It's not the actual wet the goo on your toothbrush and brush your teeth type of thing. So once I found that, then I could go back and ask the manufacturer, is it true you don't include the mouthwash in there? And they said yes. I go back to the retailer and I said, is it true you include the mouthwash in there? And they said yes. And so then I knew. So my two pieces of advice are to be curious, look at the data, and then organize it as best you can. Do your own due diligence. So when you do go back with questions, they are very specific questions.
Perfect, and that's the right conclusion for this interview. Thank you so much, Dave, for talking with us and yes, for sharing your experience and expertise about data modeling.